Just to tell you a little bit about Panologic, our mission fundamentally when we started the company 5 years ago was to eliminate the desktop PC. We very quickly realized that the desktop PC was the biggest source of pain in many IT organizations, and we knew that the world was changing. Centralization was taking hold. Everything was moving into data centers. Those data centers were owned by Google, or they were owned by hospitals, or they were owned by universities. And the idea of having a lot of PCs was becoming a problem. And so we set to try and solve this problem. And we came up with a very, very unique solution that I'm going to tell you about today. So just to tell you a little bit about the company, it was started in February of 2006. We've been around for between 5 and 6 years. We are a very, very traditional Silicon Valley startup. We're based in San Francisco, California, actually in a suburb of San Francisco called Redwood City. Like many Silicon Valley startups, we started in a garage with a couple of guys building hardware. We went to some of the most prestigious venture capitalists in the area, and they gave us money. They gave us a lot of money, in fact. So we went to Foundation Capital, and then Goldman Sachs, and then the Mayfield Fund. These are names that you probably recognize. And all in all, they've invested a total of $44 million into our company. We have operations up until this point in the United States and in Europe, in Germany specifically. And in these two areas, we have 250 resellers who are selling our product. We have our product deployed in 1,500 organizations. When I say deployed, I don't mean that we've given them the product to try it. I mean that they've installed the product and they're actively running their business on it. We have factories that run on our product. We have call centers that run on our product, hotels, hospitals, universities that use our product every single day to do business. All in all, it's a total of about 100,000 Pano devices deployed in production only in the United States and in Germany. And that's not counting the rest of the world, places like Mexico, places like the Middle East, places like India, where we just launched our operations as well. Now, I'm here to talk to you about a technology called virtualization that has fundamentally changed the way that people do computing. Let's be honest, how many of you have a data center that looks like this? You don't have to raise your hands, you don't have to admit to it, but all of us have wiring closets that look like this. And this is the biggest source of pain that people have. And the reality is you have racks and racks full of servers, and most of those servers are idle. They're running one application, and they're 95% idle. They're not doing very much work. You have to manage them, you have to power them. When they break, you have to fix them. And all of this translates into cost, it translates into time, but most of all, it translates into risk. Because the more stuff you have that looks like this, the more likely it is that it's going to break. And when it breaks, you have to explain to someone what happened and why it's not going to happen again. So virtualization was fundamentally created to address this problem, where you can take an entire data center full of servers, full of physical servers, and physical Ethernet switches, and physical routers, and turn all of this into software that runs on one server. And you can literally do this. I know this sounds like it's not possible. How could this happen? But this is the technology that was invented about 10 years ago, and it's really changed the way IT is happening in most of the world. Because you can go through this level of consolidation. Once you have all of your physical machines virtualized in a virtual environment like this, you end up with something that's more flexible. You end up with something that's significantly more secure. And you also end up with something that's more efficient. You're not wasting as much power, you're not wasting as much energy. You have just something that's more reliable in general. So just to explain to you a little bit about what virtualization is. Well, if you look at what a server is today, a server really has two components. It has the underlying hardware of the server. This is the box that you might buy from Dell or HP or IBM. And on top of that, you have software that you've loaded. You always have an operating system. Maybe it's Microsoft Windows, maybe it's Linux, and then on top of that, you have applications. Right? This is what a server is. Well, imagine if what you could do is take one piece of physical hardware, one physical server, but actually be able to run two different operating systems on it at the same time. And so instead of having a situation like you did before, where you had one physical server with one operating system and one application, and maybe that application is only using 5% of the CPU on that server, now you can have one server running two operating systems simultaneously, each operating system running its own application. That way you still have the isolation. You know, the reason why people sometimes have multiple servers is because they don't want to mix applications. They want a print server and they want a file server, and they don't want to mix the two. And so now you can do that. You can keep the separation where you have an instance of Windows Server 2003 running the print server application, and right next to it, running on the exact same machine at the same time, sharing the same underlying hardware. You can have a different operating system, Windows Server 2008 or Linux, running a file server, right? And this is what virtualization is really about. And I use the example of two virtual machines because that's easy to explain, but the reality is it's never been limited to two. In fact, typically for server type of environments, you'll get 20, 30 servers, operating systems running on one physical server. And for desktops, you'll get 50, 60, 70, right? And so this is really about, when I talk about taking a rack that was full of 20 or 30 servers and taking them and moving them onto one server, where you have a series of virtual machines running operating systems, where you have virtual switches that have replaced the physical switches, and virtual wiring interconnecting those machines, replacing the physical wiring. You really can get all of that onto one server. In fact, what we do a lot of times when we demo our environment, because our system is based on virtualization, is we can walk into a customer site with a laptop. And on that laptop, we have an entire virtual data center. We have virtual routers, virtual switches, virtual operating systems, virtual desktops, all in one place on the size of a laptop. Well, imagine if you didn't have the power of a laptop, but you had a power of a full Dell server or a full HP server. You really can do a lot of this stuff in very, very exciting ways. So the question is, what are the real benefits of virtualization? Well, the first thing is something that I've already talked about a little bit, which we call partitioning. Right? If you have two different applications, you can now run them in two different operating systems, keep those two operating systems on the same physical server, but have them be completely separate. If one virtual machine, if the operating system in it crashes, the one next to it keeps running. If one virtual machine gets infected with a virus, the one next to it keeps running. If you need to reboot one virtual machine, you can reboot it. The other one keeps running unaffected. Right? The second one is something that we call encapsulation. And encapsulation is just a fancy way of saying that, I talk about this virtual machine as being this fancy thing with an operating system and applications in it. But at the end of the day, this entire virtual machine really appears to be like one file on that physical server. And so when you have one file that represents the entire virtual machine, the operating system, the applications, the configuration, you can now make copies of that file. And by copying that file, you've effectively made a copy of the entire virtual machine. If you need to move this virtual machine from one physical server to a second physical server, you can do that simply by moving one file. If you have that file in a virtual on a storage area network, you can even sometimes move the virtual machine while it's running without even having to shut it off. Right? And I'm going to talk a little bit more about this stuff as we move on. The next thing is migration. I have started to talk about this. If you're using a storage area network to store your virtual machines, and you have two physical servers that both can see the same storage, and your virtual machine, that file I was talking about, is running on that storage, you can move the virtual machine while it's running. So if you have two physical servers and you need to take one of them for maintenance, you can move the virtual machine while it's running, uninterrupted, do the maintenance on the first server, and then you can move it back. If you have a failure on the first server, it will move right over. And same thing. You don't have to worry about the physical failures. Okay. The next benefit of virtualization is reliability. Right? When you're running in a virtualized environment, a lot of the issues that you have with physical servers go away. So for example, today, if you have a physical server and the physical server fails, that entire physical server will come down. And until you repair that hardware, you can't recover it. In a virtualized environment, if your entire operating system and the applications are running in a virtual machine, and you have some kind of a failure, you can instantly power up that virtual machine somewhere else. Within 30 seconds, it will come back online. And so you have very, very rapid recovery in terms of failures. So the real question is, how does all of this apply to desktops? Because at the end of the day, Pano Logic is a desktop company. And so when it comes to desktop computing, there's really three major things that you're contending with. The first one are the costs of desktops, right? Today, you may go and you may spend a certain amount of money on the actual PC that you put on the user's desk. But then you spend, over the course of the next 3 years, 5 years, a tremendous amount of money, a tremendous amount of energy on that PC, because you have to install software on the machine, you have to push updates to the machine, you have to make sure that the antivirus is always updated, you have to reconfigure the applications every time a change comes out or a security patch comes out. If the hardware fails, if the hard drive fails, the fan fails, the power supply fails, you have to send someone out there to go physically fix the PC, and all of the time going back and forth becomes costly. Especially if you have multiple locations. You know, you may have headquarters and you may have other locations where you might only have 20, 30, 40 people. And sometimes you don't have enough IT people in those remote places. And so now every single time a PC breaks, you're sending someone out there, and he's driving there or getting transportation to get there. These are really a lot of the costs, the hidden costs that happen with a PC. So you may buy a PC for a bargain, but then you're sitting there maintaining it over the years. It's kind of like buying a German car, right? It's a beautiful car in the beginning, but then when you get your first oil change and you realize, oh my God, this is going to be expensive. The second thing is really the amount of energy that you guys, that IT organizations spend managing their PCs is disproportionate to the value that the PCs bring to the organization. In most of your organization, you'll find that your servers are really where the vast majority of your benefits are. It's where the important assets live. It's where your databases live. It's where your mail servers live. It's where your file servers live. This is where all the important information is. The desktop is not really important. In fact, your goal should be to keep as little information, as little valuable information on the desktops as possible, because the more valuable things you have on your desktop, the more risk you have. If the desktop gets stolen or if the desktop breaks and you lose the information on it. And so, even though you really have all of your valuable information, all of your valuable applications running already on your servers, you're probably spending the majority of your energy on the desktops. And that's really what we're coming here to address. So in the exact same way that 5 minutes ago I said that you can take an entire rack full of servers and replace that with one physical server, what I'm here to tell you today is that you can take all of the PCs in your organization and you can replace them with a server using the same virtualization technology that we use to do this with servers. So in server virtualization, we took servers, a rack full of servers, and replaced them with one server. With desktop virtualization, which is what we do, we're going to take a pile of PCs and we're going to replace them with one server. So really the question is, what is zero-client computing, right? And zero-client computing is the technology that we invented. And all of you on your tables, on most of your tables, you have a device that looks like this. And this is a zero-client. And so the question is, what did we do? What did we try to accomplish when we built this, and why? Right? The first thing that we did is we wanted to completely eliminate the desktop PC. We felt that as long as there was some kind of a computer, a PC, sitting at the end user's desk, you were never going to be free of all of the problems that come with PCs, all the problems that I've been talking about up until this point. And the only way to be completely free is to really eliminate that PC altogether. What that really means is we have to take all of the software that's on that PC and move it into the data center, into a centralized place, so that in your server rooms, where all of your valuable data is, where all of your valuable applications are, you can run your entire desktop. and have 100% of your software over there. Now, when I say that, I really mean that what's left on the desk, being this device over here, has zero software on it. It has no software whatsoever. And we're the first solution that has ever done that, right? Some of you might even be thinking, this sounds familiar. I've heard of this type of technology before. The reality is that people have been attempting this now for probably 15 or 20 years. And in every prior attempt, the mistake that they made was that they left a significant amount of software on the desk. And so they say, okay, we're going to try and move 50% of the software into the data center, and we think that's good enough. And it was never good enough. And what we did when we sat in that garage and we started building our first product is we gave ourselves a challenge. And the challenge was no software, pure hardware. And by eliminating 100% of software, we knew that all the real problems would go away. Now, the way we were going to do this was by leveraging virtualization technology. Because with virtualization technology, today I may have a PC that's running Windows XP or Windows 7. And all we're going to do is take that operating system, that Windows XP or that Windows 7 operating system, and we're going to move it onto a server running in a virtual machine. And so the same way that I said you can take a server and you can boot 5 different server operating systems on it, well, now we're going to take a server and we're going to boot 30 or 50 different desktop operating systems on it simultaneously, all in one centralized place, all in one secure place. Which means that at the desktop, you have no management whatsoever. There is never a case where you have to go up to someone's desk and manage the thing that is sitting on the desk anymore. Because everything, all of the software, everything that you have to manage and maintain is running in the server room in one central place. So the question is, what do you really want to put at the desk? Because if you're going to move all of your software, to the data center, well, what do you want to put at the desk? And the answer is what you want is nothing. You don't want to put anything there. And with our solution, it turns out that what you need is also nothing because you don't have to put anything there. The only requirement that you have is today with a PC, you have a monitor, you have a keyboard, you have a mouse, maybe you have some USB peripherals, maybe it's a printer or a scanner. And all of these things today plug into the PC. Well, if I've eliminated the PC and I've moved it somewhere else, I still have these peripherals, the monitor, the keyboard, the mouse. And so what you need is you need something that allows you to connect the monitor, the keyboard, the mouse to your network so that over the network, it can talk to the server where the desktop is actually running. And that's what we've done. This device that many of you are holding in your hands does exactly that. It's simply a connection point. It's an adapter that allows you to plug your monitor into the network, and it's an adapter that allows you to plug your keyboard and your mouse and your printer and your scanner into the network so that the desktop that's running on the server in your server room can talk to its peripherals. We sometimes call this remote I/O. Does that make sense? And just to reiterate, and I know I've said this 100 times, but I'm going to keep saying this because this is the most important point. That device, the device that you have over here, the one that we're going to put on the desktop, has absolutely no ability to run any software. It does not have a central processing unit in it. It does not run an operating system, right? Because the second you do that, the second you put any type of computing capability in a device like this, you have defeated the purpose. Because now you have a device that you have to manage. The software that would be on here, you will have to update. The software that would be on here will have security holes in it, and you'll have to push patches out. But with a device like this, you don't have any of those problems. And so in case I haven't said it enough, there's no central processing unit in the device. There's no system memory, there's no hard drive, there's no type of storage. There's no software, there's no firmware. Right? There is nothing on the device that you ever have to update. It is impossible for this device to get infected with a virus. A virus is a piece of software, and viruses are software that attack other software. If there's no CPU, if there's no software on the device cannot be attacked in any way. It can't get hacked into. You never have to configure it. You never have to do a firmware update to it. You plug it in at the desk, and it just works And all of your energy from that point forward is expended in the servers. And once you have everything centralized in the servers, that's where you really win. So I know a lot of you say that we've seen this before. And so let's maybe talk about the history of what's been attempted. The first thing we started with was the PC, right? And in the PC, everything was running, all the software was running on the regular PC. And really, PCs don't rely too much on servers, just for the PC functionality. If you're running Microsoft Word or you're running out, all of this stuff is running locally. And then there came a technology called terminal services, right? This is technology that was invented in about 1995. Some of you guys have heard of this before. You've heard of terminal services from Microsoft, terminal services from Citrix, thin clients from companies like Wise or N Computing. You've heard of all of these devices. What these guys are doing is they're replacing the PC that you had with a lighter PC, a stripped down PC that they call a thin client. And then they're moving about 50% of the software in your environment into the server room. And so what you effectively have in this situation are two PCs to do what your old PC used to do. You have the thin client, which is a PC. It's just running less software than a regular PC. And you have a server running a bunch of software. And you use the PC on your desk to access the PC in the data center. It's twice as much work for you. You get the promise of centralization. You get the promise of cost savings. But in reality, you don't get it. And so this technology has been around since 1995. And it's penetrated the business PC market only by about 3% in 15 or 20 years.